Students, today we're going to do our human cardiac physiology lab. Now, we are not doctors. I'm not a doctor, medical doctor. We're just looking at how things work and so on, but we're not diagnosing anything. This is not your physical. And speaking of physical, if any of the activities are too much for you, don't do them, okay? I don't want anyone to overexert themselves or anything like that. Also, again, we're not diagnosing you with anything. Okay, so here's the heart. And your heart is actually like a fist-sized organ. We can transplant a heart because, look, it's just a matter of plumbing. It's just a matter of a few blood vessels, some very major. But it's a relatively simple organ, okay? You never heard of an eye transplant because your eye has thousands of nerves and connections, and boy, would that ever be difficult. And so the heart is super important, but it's also really just kind of a simple thing. And so we're going to just look at a few aspects of cardiac physiology. We're going to be doing an EKG. So I've got some sensors on me, and we'll hook up to a computer in a little bit and see an electrocardiogram. Now there's a K, not EEG, that's your brain electroencephalogram. So they're either called an EKG or ECG. K, I think, in German cardio is spelled with a K. But this is a record of the electrical signal produced in a heartbeat. We're going to take an EKG on the computer in a bit. Also, we're going to look at blood pressure, which measures the contracting and resting phase of the heart cycle. And the heart cycle is so interesting. Some people, like super fine-tuned athletes, they might have a pulse rate of 60 beats per minute, which is really excellent, that your heart is not working super hard when you're resting. Some people who are really out of shape, they may have a much higher beats per minute. So your heart is a muscle. It's really, really important to keep that muscle strong and to exercise and to take care of your heart. Now, some people, no matter how hard they try or how they take care of their heart, because of genetics or even diet, sometimes they will need what's called a bypass surgery. So your heart is not only pumping all the blood, but it's also a muscle, so it needs its own blood supply with these cardiac arteries. It needs to be supplied with oxygen because it's a muscle made of tissue and cells, and those cells all need oxygen to respire. Remember respiration? Every one of your cells needs oxygen, even your heart cells. So sometimes, due to genetics or due to poor diet, people get blockages. And they get blockages in the cardiac arteries. And that blockage is often caused by cholesterol piling up, causing a plaque, and that's going to block. And so someone who has a mild heart attack might have a blockage in one of their minor cardiac arteries. So what doctors will do is they'll actually bypass, they'll take some blood vessel from a person's leg, and they will actually bypass the blocked part. So in this case, this part was all blocked, so what they did was they took and bypassed and connected this right to the artery so that all of these parts of your heart muscle will get the oxygen it needs. So this would be a triple bypass right here, a triple bypass. Both of my parents had quadruple bypasses, okay? We have very high cholesterol in our genetics in our family, so I personally have to be super careful about certain things and trying to stay in shape and so on. I have a sister that's a total toothpick and eats perfectly, and she still has high cholesterol just because, that was part of our genetic makeup. But, exercising and eating right can really help to diminish some of those effects. Both parents had surgery at 70, and, a brother died of a heart attack at 49, and my grandpa died of a heart attack at 49. So our hearts are kind of our weak point in our family. You've got to really take care of yourself if you have that kind of history. Anyways, so your heart cycle can last a minute or, less than a minute. It just depends what your pulse, how many beats per minute you have. Most of your heart cycle is the chambers of your heart, there's 4 chambers, is the chambers of your heart filling. And then a very small part is when your heart muscle contracts and pushes that blood out. So, blood pressure is a measure of the contracting phase, which is that squeeze that your ventricles make, and the resting phase is that filling time, okay? That would be the systolic and the diastolic, and this would be your top number and your lower number. And we used to just only be concerned about that top number, that contracting. How much force does your heart have to push to get the blood way to the tip of your head and to the tip of your toes? That is what your top number is. How much force does it take? And if that's a really high number, that means your heart is working super hard. If you can keep your blood pressure lower, that means your heart is working less hard, and you only get one heart, although there are heart transplants. But so you want to keep your heart in shape so that it doesn't have to work super hard. If your arteries are blocked or have a lot of plaques along the vessels, your heart has to work harder. So heart health is really important. Now, the third thing that we're going to look at for a minute is cardiac output. Now, we all have a certain cardiac output, which is equal to the blood volume times your heart rate, okay? And cardiac output is a constant, all right? Shaq's cardiac output is a lot different than, my little niece who's like 4'8", a little tiny thing. But both of their cardiac outputs is their blood volume times the heart rate. So when your blood volume is very low, let's say you've been standing a long time and less blood is getting to your heart rate has to increase because this is a constant, okay? If your blood volume is high, your heart rate can decrease. So these are the 3 things that we're going to kind of talk about in the lab and look at as we go through. Now, I'm going to step over and actually do a blood pressure. Oh, later in the lab, you're going to see how long it takes you to recover after exercise. So what you're going to do is at 96 beats per minute, okay, and just like the lab says, this is called the cash test. And so just like the lab says, you are going to walk at 96 beats per minute. You can find a metronome on the internet, no problem there. And you are going to do this for 3 minutes, okay? So it's kind of like this. You can do it on a step in your house, okay? It's like one. This is about 96 beats per minute. Da, 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 da. You're going to do this for 3 minutes, just like the lab says. What this cash test is measuring how long it takes you to recover after exercise. So after your 3 minutes, as the lab says, sit down and find your pulse. You can find your pulse here in your neck. or you can find your pulse on your wrist. There's other places to find your pulse too, but these are the best places. You're going to take your pulse, see how many beats per minute, and then after resting for 1 minute, you're going to take your pulse again. And we have a fitness rating that goes along with your cash test. So some people, have you ever been with someone who is really out of shape and you're walking up a flight of stairs together and they get to the top and they're still, even though they're not going up the stairs anymore, they're still breathing really fast and really heavy. They're breathing so hard. They're not even on the stairs anymore. They're done. Okay? People who are in shape, as they're going up the stairs, they can meet that extra oxygen demand of physically exerting themselves. But people that are out of shape, even going up the stairs, they can incur what's called an oxygen debt. They can accrue a debt of oxygen in their muscles. And until that debt is paid, their heart rate is going to be elevated. So that's why they can get to the top of the stairs. They can even be leaning over. They're still breathing fast and hard because they got to pay that oxygen debt back. So that cash test is just showing you, hey, you know, are you able to meet the demand of 3 minutes stepping at 96 beats per minute while it's happening? Or is your heart going to remain elevated for a while as you pay that debt back? Again, if you have any kind of physical issues, you know, have a friend do it, someone who's in better shape. You don't have to do this yourself. But I do want you to see how the heart rate changes as we, you know, exert ourselves. Okay, students, so we're going to do a blood pressure measurement and we're going to do an EKG here. Now, blood pressure. You can see on this simple dial, I've got a 140, 170, 200, 240. Well, I know that my blood pressure is around 140, so I've got it set on the 170. What that means is I am going to squeeze my arm with a pressure of 170 millimeters of mercury. It's just a weird unit. Okay, I'm going to squeeze it with 170. And then the cuff is going to slowly release that pressure. While it's at 170, no blood will be getting through to my extremities. Okay? No blood will be getting through. When it reaches my blood pressure, which is, again, the systolic, the squeeze of the heart, when that is reached, now blood can slowly start getting to my extremities. So you never want to take someone's blood pressure and then, you know, pump them up or, you know, get it pumped up and then go walk away and, you know, get a sandwich or something, because their extremities aren't getting blood and your cells die after just a very short time if they're not getting blood. So I'm going to just turn this on. It's very simple. And I don't want to talk while I'm taking my blood pressure. And so I'm going to stop talking. It's going to pump up to 170, slowly release, and it's going to take my diastolic and my systolic blood pressure. Okay? So let's press start. Okay, so my systolic, 135, my diastolic, 86. That means when my heart contracts, it has to contract with a force of 135 to get blood everywhere. I used to be like 100/60 or 90/60 and 10, 15 years ago. And as I'm aging, my blood pressure is creeping up, which means my heart is working a lot harder, okay? You can see my pulse is 82. That means 82 beats per minute. Now, what is interesting is your blood pressure can change so quick. My mom had white coat syndrome, which meant I would take her blood pressure at home. It'd be 130 over 90 or 130 over 100. It would be fine. Gets to the doctor's office, literally 10 minutes later, her blood pressure would be 170 over 150. The doctor would be panicking. It's so high, blah, blah. I would say, I just took it at home, and it was fine. When you work yourself up, even the other day, I was thinking about this stressful situation at work, and I took my blood pressure, and my blood pressure was much higher than it normally is. I stopped thinking about it, took the blood pressure again, it had gone down. It is a fact that stress kills. And if you are in a constant state of stress, that's not how your body is supposed to be, okay? So, stressing yourself out about things like I was stressing out over something at work, and honestly, I could not believe the effect on my blood pressure. My mom would get that stressed out because going to the doctor, such an effect. Your health is really important. If you are getting stressed out all the time, you gotta find a different way of living. You gotta just meditate or slow down or whatever. Think about something beautiful, get calm, whatever you do. Because stress does kill, that is a fact. Okay, so another thing about when you take your blood pressure, you can't have your legs crossed. That can affect your reading. You should have your arm resting, and it should be like around your heart level or a little above. So anyways, again, I would tighten. The squeeze was at 170, and then it slowly let up. When it got to 135, that's when my blood was able to get through again. That bottom number again is the resting rate, okay? That's your diastolic measurement. Okay, so you're going to do the manual blood pressure measurement. You're going to do a blood pressure measurement. Hopefully there's some way you can measure your blood pressure. If not, then just answer the questions based on what my reading was and what I was discussing to you about what was happening with people I know and with myself even. Okay, now we're going to do an EKG, and these are really, really cool. Okay, and so I need to hook myself up. I need the green and the black, and then the red all by itself. So I'm going to put the red over here. And what we are now going to be measuring is the electrical impulse across our heart. Okay? The electrical impulse. And we are going to be getting a EKG, okay? Typical EKG looks like this, okay? This is called the QRS wave, and that's for the actual contraction. This is 1 beat, this is 1 beat, this is 1 beat. These are showing the filling of the chambers, okay? The filling of, so there's several nodes on your heart that give electrical signals. Your heart is, you have voltage in your body, your brain and your heart, both. You can get an electroencephalogram, which is measuring your brain waves. You can get an electrocardiogram, which measures your heart. Okay? So what we're going to do is I'm going to just sit relaxed, and I'm going to collect data on the monitor here. Now, notice all this chatter here, all this disturbance. That could be because I was just talking. In fact, let's have some fun, and I'll press collect and I'll be talking. So this is when I'm talking, so you can see there's a little, and now I'm going to try to remain very, very calm. But I did drink a lot of caffeine this morning. And so this may all be due to the caffeine. Okay, let's see. Wow, something must have come unhooked. What just happened? Okay, so let's do it one more time. Now, if I had hooked these up backwards or something, we might see the QRS wave going down. Okay, so what we're going to do is we're going to measure my P wave, my QRS, and my T. You're going to put data in these, and I will write down the data for you while we're doing it so that we don't get too confused. Okay? All right. So we'll just have to use this trace. It must be from the caffeine from this morning, because a typical trace doesn't have all that noise. See how much smoother this is? It's much smoother. But caffeine does kind of get you a little bit jittery, or at least it gets me jittery. My husband, on the other hand, no, but it does get me jittery. All right, so what we need to do is we are going to use the x equals here, okay? And it says, when data collection is done, click on the x equals and move the mouse along the graph. And we are going to do first the P wave. As this particular diagram says, that the P wave is actually that first bump, okay? All right, so we're going to call this, see how there's a P wave here, there's a bump here and here, we're going to call this our P. Okay, we're going to first go to the x equal, we're going to bring it down here, and we are going to go to the, see what the measurement is there, okay? So it says for the P wave interval, our starting time is, when we put it here, we can see it starts at 0.63 seconds. And our ending time, it ends at the base of the Q, which is 0.72 seconds, okay? So we've got our 0.63 seconds, and then we go to the end of that, 0.72 seconds, and that means when we subtract those, we end up with 0.09 seconds, not even a tenth of a second, okay? Now let's look at our QRS. Our QRS starts at 0.72 seconds, starts where the P ended, and now we're going to take it over to here, which is 0.79 seconds, okay? And so that is 0.07 seconds. Our T wave is from QRS from down here all the way back to the P. So we ended at 0.79 seconds. And now we are going to go to our next P. Remember, we started at this. Our next P would be right there. I'm going to take that and go right over to here. And that is at 1.38 seconds. Okay? So 1.38 minus 0.79. 1.38 minus 0.79 is 9.59. Okay. 0.59 plus 0.07 is 0.63 plus 0.09. Oh, interesting. So we end up with a total for one of my heart cycles based on this EKG, 0.72. Remember, I was at about 82 beats per minute? so that does make sense. 82 times 0.72, that should be about a minute. So that makes sense. So anyways, what this is showing you, look at what a tiny amount of the entire heart cycle, the actual squeeze is. It's 0.07 seconds. It's a very small part. Most of the time, your heart is filling. Okay? Very little time it's squeezing, but we pay attention to the squeeze, you know, because that's what we feel. Now, my husband has a heart murmur, so if you're listening to his heart, every few beats, it skips a beat. And it'll be like bing, 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 bing. And it's really kind of interesting, but it's not dangerous. Okay, so now we're going to look at the questions real quick. How do the blood pressure values manually from the computer program compare? Anyways, all I want you to do there is discuss a little bit about the blood pressure. Talk about the difference between when you're stressed out and you're not stressed out. Okay? How does your EKG trace differ from the typical? This one is the typical. This one is mine. Go ahead and you can make some comments. The most obvious difference is that noise. Okay? All right, the next thing you are going to do is you are going to select somebody. You know, you're going to do this in a group, so one of the group members can do it. Okay, and you're going to see how different things that you do will affect your heart rate. So you need a normal heart rate, okay, a resting rate. Remember, you can use the fingers. You can do 30 seconds worth and then multiply that by 2. Okay, so let's say mine is 82, which the blood pressure machine said was, okay. After exercising, so what you need to do then is exercise. You need to run around the room, you need to do, you know, go for a bike ride, whatever, however you want to exercise. You're going to now take your pulse again, and you're going to write it down. After hyperventilating, to hyperventilate, you're just going to breathe really, really fast, okay? Hyperventilating means too much oxygen, too much, okay? So I don't know if you've ever seen someone hyperventilating, sometimes like in a swim meet or a track meet or somewhere where people are really exerting themselves, they will hyperventilate. You just need to breathe fast for like, you know, a minute and then take the pulse, okay? After breathing in a bag, you get a paper bag and you're going to breathe in that bag, okay? It says for 2 to 3 minutes, all right? You're going to increase the level of carbon dioxide in the blood because now you're breathing in carbon dioxide instead of oxygen. How is that going to affect your pulse rate? And then after being startled, so at some point you got to tell someone, you got to scare me at some point, you got to startle me. After you're startled, sit down, take your pulse. You want to see how these various things affect your heart rate, okay? The next part is the capacity after exercise. That's the cash test where you're going to step up and down a step at 96 beats per minute for 3 minutes. Sit down, take your pulse right away, and then after a minute, take your pulse again. And you're going to use that one after a 1-minute rest period and see what is your fitness rating. Now, if you come up with an excellent fitness rating and you know you're not in excellent shape, don't think that means you can keep eating junk food and laying around the house, okay? This is not a diagnosis. This is just, you know, our lab for our purposes, okay? Get your physical, you know, every so often. You know, you kind of are what you eat, what goes in. You know, you're either nourishing your body or you're wrecking your body. So, you know, make your choice on that. Okay, now the questions are very simple. How did each of the activities in Part C affect the heart rate? So that would be when you were hyperventilating, breathing in the bag, exercising, how does that affect the heart rate? Okay, that's an easy question. What were the results in Part C what you would have predicted? So if any of those were kind of things you didn't think would happen, like when you load your blood with carbon dioxide by breathing in a bag, you might think, oh, you know, that's going to make my heart go faster because of this, or that's going to make it go slower because of that. So just discuss what you thought might happen and what actually happened. And then question 3 says, what factors might have caused results that are contrary to what you would have predicted? For example, okay, if somebody didn't get any sleep the night before, or if they had to take an allergy pill, or like me, I drank too much caffeine this morning because I knew I was filming for 4 hours, so I need some energy, right? So you need to think through number 3. Why would this be this way instead of that way? Okay. Now, 4, chronic high blood pressure is typically referred to as the silent killer, since an individual may have high blood pressure and not know it. Why is it so dangerous? Remember, your blood vessels are, they carry the blood, and the more pressure they're under, if you have high blood pressure, that means your blood vessels are always under high pressure. Let me poke at this balloon. Let me put this balloon under high pressure for a long time. Eventually, what's going to happen to that balloon? I'm going to wear right through that thin wall, and when that happens, when a blood vessel bursts, that's called an aneurysm, and that can be very, very dangerous, depending on where it is. If it's in your brain, it can lead to a lot of debilitation. So you want your blood vessels to not be under high pressure all the time. And a lot of people take high blood pressure medicine. My husband's a very thin man, very healthy, but he just genetically has high blood pressure, so he has to take high blood pressure medicine. All right, 5, for a while, systolic, the top number, was thought to be the best indicator of high blood pressure. Then we thought the diastolic, the bottom number. Currently, it's back to systolic. Why might systolic be the better indicator? Why might diastolic be the better indicator? Remember, one is a measure of only when that contraction is happening. Remember, the contraction is only a very small part of the heart cycle, 1/10 of the whole cycle. 9/10 of your heart cycle is the chambers filling. 1/10 is the squeezing. Okay? So your systolic is during that squeeze. Your diastolic is during that 9/10 of the heart cycle where things are filling up. So that's what number 5 is about. If you're going for a great grade on the lab, you really need to kind of think things through and explain these things. All right. The next one is all about the cardiac output. Okay, so you need to refer back to that formula, cardiac output. Remember, cardiac output is equal to heart rate times blood volume. Okay, this is a constant. So if one goes down, the other must go up. If one goes up, the other must go down. Okay, and then in the cash test, you're going to talk about, when I was discussing if you've ever walked up the stairs with someone out of shape and how it takes them so long to get their breathing back to normal. So that is what number 7 is about. And let's look at the last question, was number 7. So we're done with the human cardiac physiology lab.